The RX 7900 GRE from AMD is kind of a weird graphics card when it comes to testing its performance, because in some games it gives you this huge boost, in other games not much, compared to the 7800 XT that we had at a very similar price point, in addition to all the weirdness of the Chinese-only launch at first and then opening up recently in February to everybody else. I'm using the Power Color Hellhound model that I got sent for a review sample in this video, and like to give you an idea of what I'm talking about, for example, in Cyberpunk with 1440p RT overdrive mode versus 7800 XT, I found the 7900 GRE was 21% faster. Whereas if I just went down to just 1440p Ultra without any ray tracing, it was only 7% faster than the 7800 XT. And if we jump into some other games, you can see differences all over the place. If I jump into RoboCop Rogue City, an Unreal Engine 5 game, epic settings, we're seeing like 9% difference. If we jump into, maybe Avatar Frontiers of Pandora, which is a ray tracing title, 12% gain here at 1440p Ultra. So again, the differences are usually more consistent than that between GPUs from the same brand, like AMD versus AMD within the same architecture generation, all of that. So what was going on here was the fact that the 7900 GRE, when compared against the 7900 XT and the 7800 XT, which price-wise it's kind of slotting into, we saw some kind of strange stuff. I'm going to shrink down and become a mouse pointer. We saw that if you look at its stream processors, or in general just its compute units, the 7900 XT only has 5% more compute units than the 7900 GREs, but it has, if you look at the 7800 XT going to the 7900 GRE, you're getting a 33% compute unit increase, which is quite a bit. But if you look at the memory bandwidth, the 7900 GRE going to the 7900 XT, the 7900 XT is an increase of about 39% memory bandwidth, from 576 gigabytes per second to 800 gigabytes per second. And if you look at it from the 7800 XT as going to the 7900 GRE, you actually lose 8% memory bandwidth going to the 7900 GRE. Now, why is that happening? It's largely the memory speeds and the memory bus. So the 7900 GRE has the same memory bus as the 7800 XT, which is 256-bit versus the 320-bit bus on the 7900 XT, and the memory speeds for the 7900 GRE are at 18 gigabit per second. Which is not only slower than the 20 gigabits per second on the 7900 XT, but it's even slower than the cheaper 7800 XT, which is what's leading to these weird performance differences, where if the GPU is primarily limited by just it could use more cores, then we're seeing the larger performance jumps. But if it's more limited by memory bandwidth, we're not seeing much performance gain compared to the 7800 XT, which leads to those kind of weird experiences that we're seeing there. But a lot of people pointed out at launch, man, we could probably just overclock that and gain a bunch of performance. But the problem was, on the launch drivers for the GPU, you really had extremely limited memory overclocking potential, which is why it's very interesting to now see articles like this. This one's from Tech Power Up, but there's other places reporting on this, that AMD's newest GPU drivers have unlocked the 7900 GRE memory OC limits for additional performance. And Tech Power Up is showing that they were able to get their Power Color Hellhound, which is the same model I have, up to a total of a 15% overclock performance improvement compared to at base. And I believe that they're, and just using the memory performance, it looks like they were able, I think this is what they were able to do at launch, and then this is now on the newer drivers. I think it's how we read that, yeah, because we're on the newer driver listed right there. So they were able to unlock a lot more performance from the card. Now, the weird thing is with overclocking, though, is that, I hate people, like, a lot of people say I should do more overclocking in my benchmark. I see that comment a lot. My problem is that you're only ever guaranteed when you buy a graphics card to get its out-of-the-box performance, which leads to those kind of weird experiences that we're seeing there. But a lot of people say I should do more overclocking in my benchmark. I see that comment a lot. My problem is that you're only ever guaranteed when you buy a graphics card to get its out-of-the-box performance, you aren't guaranteed to be able to overclock your GPU the same amount that, a YouTuber or a review outlet of some kind is able to do, because it can depend on the specific silicon quality. So I do want to mention that before I go ahead and do what I'm going to do next, which is I'm going to toss in my 7900 GRE, and we are going to try this out and see if we're able to get a bunch of boosted performance on mine. But again, keeping in mind that your results may vary because of limits to silicon quality, which is why I would have preferred if we maybe just had a better memory speed out of the box. It's unclear why they did this in the first place. Maybe it's to keep the same power targets as the 7800 XT so that maybe they could just use the same cooler models or something like that for AIB partners. I don't know. Anyway, I'm going to go ahead, pop in my 7900 GRE, and we're going to go ahead and do a little overclocking video, test it out, and see what kind of performance gains we can get. All right, so I have the 7900 GRE kicked in, and what we're doing right now is running a baseline test on the old driver using Cyberpunk as kind of a game, to actually measure in-game performance, but using the built-in benchmark run so we can get, extremely limited run-to-run variance messing with our results. And so this is 1440p ultra settings. Like I said, Cyberpunk built-in benchmark, there is no overclocking, and we are on the old driver. So this is our absolute baseline, and you can see the stats overlay I'm using here is just the one built in from AMD's driver software. And also, capture-wise, the capture right now is being done on a second PC using a capture card, so there's no capture happening on the PC running the game. So that is not impacting performance. It also means that sometimes you'll get some screen tearing and things like that, because I don't have VSync enabled, and it's a capture card, so limited variable refresh rate kind of doesn't really kick in. Anyway, the point is that's the capture method we're using for all of this, and we'll go ahead and use Cyberpunk's built-in benchmark results. And you can again see the memory speeds and whatnot and all that. But we're getting 95. Again, this is 1440p, no upscaling. It says preset is custom because if you kick onto Ultra, that would include AMD's FSR enabled by default. So I've disabled that, and that's why it's reading as custom. So we can see that that's the baseline results is 95 FPS. And if we go to the tuning section, you can see that we have, let me get this overlay out of the screen so it's not bothering us. So we can see that right now everything is just on default. I do have smart access memory enabled. And you can see my system specs in the video description. It's a 7800X3D based system, so we're not getting CPU limited and all of that. So now what we're gonna do is look at a quick overclock. So we are going to go to the GPU tuning, and we are going to enable some custom tuning, and we have to accept that, we accept the consequences. Anyway, this isn't really a overclocking guide, nor am I exactly an overclocking expert, although I do play around with it from time to time. We're gonna kick on VRAM tuning, and we're gonna look at on the, again, what driver version we're on right now is the 24.1.1. I have not downloaded the new one yet. So we're looking at the limited overclocking ability on the original driver. So that's what we're looking at here. So VRAM tuning, and let's see, we could try going to fast timings, and we could go to advanced controls, and we can basically look at how fast it would let us go. So you can see it's extremely limited. If you turn that off of advanced, you can see it as a percentage. It was only allowing a 2% max frequency boost on the memory frequency, which is extremely low. We're gonna go ahead and apply changes, although we did at least go to fast timings and this. Now, there's no guarantee even this is gonna be stable. I actually have not tried overclocking this card yet, so let's go ahead and run the benchmark again, with that being the only changes, and we're gonna go ahead and see if we get any noticeably different results. Let me kick the overlay back on. And again, on the left-hand side of the screen, I am showing things like the memory utilization, memory clock speeds, things like that. So we can go ahead and see if we get any kind of meaningful difference. But again, this is on the original drivers. So that only 2% boost to the memory clock. You can see it is showing a little over 2300 megahertz here. And yeah, we'll go ahead and see if we get anything better than about 95 FPS. We're running to the end of the benchmark run. Everything seemed perfectly stable, and we got up to 97.85. So we can see that there was a small performance increase, but extremely modest by maxing out the memory overclock on the original driver. So what I'm gonna do next, and you don't need to sit around and watch, is I'm gonna download the newest driver, and then we're gonna see what else we can do on that. All right, I've installed the new driver, and what we're running right now is no overclocking on the new driver, because often, if you compare game performance on different driver versions, you can actually see a few percent change just by changing the driver version. So it's important to look at what we got on the last driver without overclocking, and what we're getting on the new driver without overclocking, so we can see if our performance is better now. Is it because of the improvement to overclocking, or is it because of the new driver, or some combination of the two? So that's what we're looking at here. So if you look at the memory clock speeds and all of that, you see we're around 2238. So this is no memory overclocking enabled at this time, but once again, we are on the new driver, and we are in the same Cyberpunk settings, 1440p Ultra, but with upscaling disabled. So it is running at the native 1440p resolution. We're using the built-in benchmark again, so it should keep run-to-run variance to a minimum. And here we go with the results. Looks like we've got 100.97. So actually it does look like the new driver is performing better than the old driver, even without overclocking. So now what we're gonna do, let me get that overlay out of our way, is we are going to now kick on the custom tuning. We're gonna go to VRAM, and you can see now that the slider goes all the way to a 33% boost. Now that doesn't mean we're gonna be stable at a 33% boost, but remember last time we had a 2% boost as our maximum. If we go to advanced controls, that means before we were able to go to, about 2300 was the farthest it would let us go. This one will let you go all the way to 3000, although again, don't expect that to necessarily work. It's very likely that that would crash. What I think I'd like to try is a 15% boost. And because I think that should put us to just under 2600. That's a little bit less than what Tech Power Up said they were able to get. And usually when I'm doing an overclock, I like to look at what other people were able to achieve on the same graphics hardware, see if that's stable on mine. If it's not, reduce it a bit. If it is, increase it a bit. But let's go ahead and start with that. We're not gonna try any of the timing changes yet or anything. Let's go ahead and just kick on the benchmark run and see what happens. I'm also gonna kick the overlay back on so we can go ahead and see if we're actually getting the memory clock speeds that we should be. So again, we should be a little bit under 2600 megahertz now, which is a significant improvement over the stock speeds. And yeah, it's looking like we are seeing 2575 for our megahertz. The other thing you want to look for when you're doing overclocking, I mean, you want to look for stability, like is it crashing? That's the most obvious thing. But you also want to look for artifacting. I don't think I see anything yet, but that's one reason why I'm doing the video footage here. Sometimes you'll start to see little sparkles and things show up if you're right at the edge of, basically your overclock isn't actually stable. But you're not actually crashing. But I am not seeing any weird little sparkles or other artifacting issues. It is looking like the memory clock is staying at 2575. And I'll mention that I haven't done anything to increase the power limit of the card other than on all of test runs I've been doing, the GPU was at its out-of-the-box settings, which did include, it has a dual BIOS, as an OC BIOS and a silent BIOS, and it does default to the OC BIOS, which does give it more board power than the like reference model would. But hey, it looks like we got 4.62, so it's looking like we got about a 4.5% performance increase by doing the memory overclock. Now, I'm gonna try pushing this a little bit further. Let's see if we can hit 2600. Let me actually look over, what did Tech Power Up say they were able to get? Because we were slightly more conservative. I think they hit 2604 stable is what they said they were able to do. Let's see if we can match that. Okay, I don't see any issues at first. You know what? Let's go ahead and actually see when will it just start giving me issues. So I'm curious if I go to 2620, because sometimes you can actually just see it give you issues before you even do any sort of a stress test. 2630. Okay, you can see the artifact there. We got it to crash, 2648. So it looks like we definitely can't push that high, right? The whole thing's crashing. I think I'm getting a total system lockup here. Black screen. Yeah, it's looking like the whole PC is going to reboot. So I'm going to go ahead and deal with that and edit that little time frame out of the video. All right, I've done a bunch more overclocking off camera to not waste your time. And so I've played around with a few things. First of all, I did back off the frequencies to 2588 again. I did occasionally crash when I was over 2600. I also tried kicking on the fast memory timings, but while that's stable at the default frequencies, I could barely push the frequencies if I kept the fast timings. And I also tried increasing the power limit, which this card will go up by 15%. Didn't really affect stabilities on any of the memory stuff. So additionally to that, I decided to then also play around with some of the core clock stuff. So here I pushed my max frequency all the way up to the top and kept my minimum frequency just really close to that at 2700. And then I've actually undervolted the card down to 950. By doing that, I was actually able to better hold these max frequencies. I haven't tried pushing this much lower than this, so I'm not going to say that this is the best overclock you could ever achieve on this card, but let's go ahead and give a run here. So to be clear though, what you're seeing is not going to be just a result of the memory tuning. This is also a GPU clock increase as well. I've enabled the GPU clock speeds in the overlay now. So you can see that they will be between the 2700 and 2800 min-max that I've set. You'll also see that the board power is up over 300 watts now. So this is definitely drawing more power in order to do this. Although because of the undervolt, this is not drawing as much power as when I didn't try undervolting. That's one of the things about AMD GPUs, if you're not familiar with overclocking them, not that I'm some like super expert on it myself, but the undervolts can do quite a bit actually to help your clock speeds be able to go up. So this again is the result of the highest I could push my memory speeds stably, which remember that was getting us around 104.5 frames per second on this built-in benchmark run. We've now increased the power limit, taken down the undervolt a little bit, pushed up the GPU clock speeds, and the overall result of that has seemed pretty stable in Cyberpunk, but again, I haven't fully stress tested this in a wide variety of games or anything like that, but we can go ahead and at least see what we were able to achieve. So I'm getting 110.45. So overall, that's pretty interesting. As a bit, again, of an AMD just kind of interesting note, if I kick the voltage all the way back up to where it started at 1050, I think we'll actually get a worse performance out of it. So I'll kind of leave you guys with that note on AMD overclocking. So notice that when we had it undervolted, the GPU clock speeds were able to stay between 2700 and 2800 megahertz. But watch, you can already see the clock speeds are much lower than that. And notice the board power as well. So see, interestingly now, we're actually falling below 2600 megahertz on the GPU clock speeds, and the board power is going up closer to the 330 watt limit. So that is just, like I said, something to bear in mind when you are doing AMD overclocking, is sometimes pulling back that the voltage will actually boost your clock speeds and performance while decreasing power, which can be interesting. But again, you have to make sure this overclock is actually stable, which is more complicated than just running the Cyberpunk built-in benchmark, which is unfortunately all I really have time for in this video. It would be interesting, to try out my full test suite of games, make sure all of them are stable, make sure, and just measure the performance increase in each game, because as we've seen, some games are going to be more responding to memory boosts than others. Also, some will respond better to clock speed increases. Notice our clock speeds here are down below 2600, and our performance boost here was only at 16.8. So interesting stuff. Like I said, playing around with that. Like I said, I went down to 950. I didn't even try going lower. I probably could, but we're already kind of hitting near the max frequency this was going to target anyway. I did try the built-in stress test that it has, but I didn't, like I said, try a bunch of other games or anything like that. But that's what we got for you in this video overall. I think it was kind of fun to talk about the AMD overclocking and all of that. I don't do much overclocking stuff in my videos. And just a bit of a side note, I don't use overclocking results in my GPU reviews because, like I said, individual quality of the specific silicon in the specific model has a lot of influence on what you're able to achieve from an overclock versus out-of-the-box performance, which is what you're guaranteed to get. So my reviews are still going to be based on out-of-the-box performance, but it is interesting to play around with the overclocking that we're able to achieve here. And like I showed, this is repeatable by bringing the voltage down. Notice that the GPU board power is lower. We're not sticking to the 330 watts. Although this is still above the out-of-the-box settings. It's lower than when we hadn't pulled down the voltage. And notice the GPU clock speeds are once again nicely between 27 and 2800. So overall, pretty good overclock out of this thing, stable in Cyberpunk, but like I said, haven't fully verified everything, but still cool to see the increased overclocking potential now on this new GPU driver. Plus, we just saw some increased performance on the new GPU driver, which was nice to see as well, at least in Cyberpunk. That's always going to be a game-to-game variance type of situation. And I think that's what I got for you guys today. Hope you guys enjoyed the video, doing a little overclocking, which isn't something I do too often. And I hope all of you have an excellent day.